Okay, I'm going to take you through this chapter 2 practice test. Make sure you understand everything on this practice test before you take the actual test. Okay, so let's go over this. This is what you're going to be expected to know going into the chapter 2 test. The first graph, we know this is in vertex form. The whole idea of vertex form is before we even type this into our calculator, we should know that our vertex, so when I'm going to state the vertex right away, I know it's to the left 4, which means it's a -4 for the x value of our vertex. And then once you go to the left 4, you're going to go up 8, which makes -4, 8, my vertex. So I'm going to plot that point. This is going to be the highest point on my graph. Okay, so -4, 1, 2, 3, 4, 5, 6, 7, 8. Right there's my max. So is the vertex a max or minimum? Obviously, it's going to be a max. We knew that ahead of time because of that reflection. Okay, so I'm asking for 5 dots. I already plotted the vertex. I cleared my calculator. I'm ready to go to the y equals screen, and I'm ready to type in negative parentheses x plus 4, square it, plus 8. I can see that my graph's going to be opening down. I want to position my table. So I want to see the vertex. I want to see that -4, 8 on my table. I hit second graph. That brings up my table. I'm going to position my table so I can see the vertex and 2 dots above it, 2 points. So I see -6. I go up 4. 1, 2, 3, 4. There's a nice dot. I also see -5. So if I go 1, 2, 3, 4, sorry, 1, 2, 3, 4, 5, I'm going to go up 7. 1, 2, 3, 4, 5, 6, 7. That takes care of the left side of that graph. We're going to have symmetry. So when I go over, I'm going to see -3, 7. That's this dot. And then I'm going to see that if I go over 2, I'm going to go up 4. And it should make sense that we see symmetry. So connect your dots, draw an arrow to let someone know it goes down forever. It's going to continue to get a little bit wider, but it's going to open down. Okay, that's all I need for a sketch. And then we are going to just answer the same questions that we saw in our quiz. So identify the axis of symmetry. It is a vertical line that cuts this u in half, and that's going to occur when x is -4. Okay, that is your line of symmetry. Whatever your x value of your vertex is, that is what you're going to do for your line of symmetry. Not everyone knew this on their quiz, but the domain for all quadratics is all real. I can plug in any number for the input, decimals, fraction, irrational, rational numbers, it doesn't matter. It's going to be all real numbers. Okay, now my range though, I can see this from my table. My highest point is 8. That means all the other dots would be below 8. So put equal to 8. So 8 is part of your range, the y value of 8, but then all the decimals, all the numbers that are less than or equal to 8 would be included. Okay. And now, as far as the intervals, anytime you have a max, okay, you need to realize if you have a max, your dot is sitting on top, it is going to increase to the left. So increasing on the left of the vertex. And once it hits the vertex, then it's decreasing on the right. Decreasing. So on your test, I'll have the words increasing, I'll have the word decreasing. You just need to have left and right. So don't mix them up. If it's like I said, a max, we will always have this scenario. If it's a min, it's the opposite. Okay, so if it's a minimum, it's decreasing on the left, increasing on the right. Okay, so that takes care of vertex form. The next problem is a simple intercept form. So it says find the x-intercepts. That's the power of intercept form. I look at what's inside the parentheses and I think, hey, what makes that a 0? So my x-intercepts, and you'll confirm this on a calculator, But we should be able to look at this and know that -5 is an x-intercept, meaning I put a dot along the x-axis at -5. So -5, 0 is a point on my graph. Same thing with +1. So +1 is an x-intercept. Okay. Now, as far as where I say calculate the vertex, you need to remember your vertex is located halfway between your intercepts. Okay, so you can just simply add these two numbers together and divide by 2. Okay, so in this case, I get -4 divided by 2. I know my vertex is going to occur when x is -2. So I'll know exactly where to go when I type this rule into my calculator. I have x plus 5 in parentheses, and I have x minus 1. Another thing that we should understand, since I don't have a negative, I don't have a number in front, it is just a U that opens up. So when I graph this, I can see it is just a U opening up, no stretch, no shrink, no reflection. And so I'm just going to go to my table and look for -2. When I find that, I'm going to see the lowest point. I'm going to see that this vertex is a minimum. So -2, I can see that the y value of my vertex is -9. So vertex is -2 and -9. I'm going to plot that point. So -2 down all the way to -9. And then just before I make my U, I like 5 dots. So I'm going to plot -3, -8, and I see -1, -8. Okay, that's just going to help me make a nicer parabola when I connect my dots. Okay, and it should make sense. I can see that line of symmetry. So that vertical line that cuts this U in half is when x is -2. X equals -2 is the line of symmetry. Okay, it's my x value of my vertex. That's all I'm asking for that problem. Here we have a linear situation. So I did tell you that on our chapter 2 test, I need you to be able to demonstrate to me that you can do a rule for a line. Okay, I'm hoping that you can think back to algebra 1 when you dealt with linear situations and you can see the process and compare it to how we're writing quadratics. So this one, we need y equals mx plus b. Okay, now I have this on our sideboard. This is common knowledge that your slope is going to be the y's subtracted. Again, I don't care which one's y sub 2, don't allow that to confuse you. But then the corresponding x values go on the bottom. So all that means is I'm going to look at this y value of 45, and I'm going to subtract this y value of 30. Okay, since I started with the 45, underneath I must start with this x value. Okay, and so it's simple calculation, nothing hard here. You're going to see that 45 minus 30, that's going to be a 15. This is just a 3. We're going to see that we have a slope of 5. We're increasing by 5. So just understand what y means. We are dealing with dollars, okay, money, and hours. So we're increasing $5 per hour. That's what I need you to understand. So I know y equals 5x plus b. Now here I can clearly tell the y-intercept is 20, but let's say I didn't show that. Let's just say I didn't have that visible for you. If you can't see the y-intercept, you take one of the points. So I'm going to take this x, y here, and I'm going to replace the y with a 30. I'm going to replace the x with the 2, and I'm going to simply solve for b. And you're going to see real quickly that you get 20, which matches up. We knew that. I could see that my starting point was $20. Okay, so putting all that together, we now have a rule for that line. We know it's going uphill. Okay, it makes sense to be positive. We can see that it starts at 20. If I wanted to, I can plug in my 2. That's where the 30 comes from. If I plugged in a 5, 5 times 5 is 25 plus the 20 starting amount. That's where I get a bill of 45. Okay. So then once I have a roll, I can easily ask, as long as you know that your X represents hours. So if I tell you 7 hours, I'm going to calculate my bill when I replace the X with a 7. So you can pick up a calculator. If you needed a calculator, you can simply take 5 times 7, which is 35, plus 20. You're going to see it's $55. Okay. Not too bad to rent a canoe. And that's all I ask. And I could ask you a whole bunch of other different questions and stuff. I could ask you 10 hours, or if you had to rent it for a full day. So make sure you know how to write a linear situation. Okay. Now you're going to see some application problems with quadratics. You simply need to use your calculator. Okay. So I have a quadratic and it's in standard form. I even tell you, enter the equation in your graphing calculator and use the table. But it's going to be very important that you know that your inputs, your X's, are really going to be months, starting with January. So when we look at our table and we see that X is 1, we're going to realize that's the month of January. And then the Y value, the number next to it, is going to be the number of animals in thousands. Okay, so as long as you go into the word problem knowing what your inputs are and your outputs, this should be very easy to be able to then use a calculator to answer the questions that I'm going to have on your test. So this is, again, just practice typing in 2.75 x squared, that's what makes it quadratic, minus 33x. Please don't mess up typing this into your calculator. And I can see that I can just double check to make sure nothing was mistyped. Okay, it makes sense that I took what's on paper, put it in my calculator, and now I just need to go to my table. So I want to find January. So I'm going to position my calculator so I start with a 1. I see in January that how many animals are located in January? That's the first month. There are 99.7 thousand. Okay, just remember it's in thousands. It tells you that in thousands, and that's animals. That's January. October is the 10th month. January, February, March, April, May, June, July. There's August, there's September, there's October. And now we know we have 75,000. Okay, I'll write it that way. You could write the word thousand if you wanted to. So that's that first question. And you're going to see something very similar on your test where know what your X's represent, know what the Y's represent. Okay, if your Y's are dollars, I want to see you label it dollars. Okay, now I'm looking for 42. When is the population 42,000 animals? I'm going to look for 42. So it looks like it happens twice. So just be aware, because of symmetry and stuff, I need you to understand that I'm looking for April. Okay, the 4th month, January, February, March, April. I see 42, which represents 42,000. And then I also see it in August. Okay, so the 8th month, which is August. Okay, so then I ask you basically to tell me what is the vertex. So in this situation, I need you to see when X is 6, the 6th month, which is June, we had the lowest point of animals. We only had 31,000 animals in the month of June. So what is the lowest animal population based on this table, based on this situation? You can see the lowest point was 31,000 animals. And that occurred in the month of June. I can spell June. June. Okay? Again, expect something where it will be a quadratic situation. You'll use your calculator and the table of your calculator to answer questions. Okay, that's a very important skill to be able to understand. Make sure you know inputs and outputs. Okay, nothing hard there. Here's another situation. Okay, another little word problem. This time I have it in intercept form. Okay, so the calculator can accept the rule. Okay, so again, we're launching a water balloon, and it's going to follow the path of an upside down U. I know it's upside down, and I know it starts at 0, and it's going to end after 3 seconds. So it's only in the air for a total of 3 seconds. So I kind of do a quick little sketch. It's here's 0, here's 3. Those are my x-intercepts. I need to find the vertex. Okay, so this kind of ties into your big ideas, the 2.3 section where you were dealing with intercept form. But we can type this into a calculator. Instead of a t, use an x. T stands for time in seconds. And I'm going to have x minus 3. Now, the problem is the halfway point is going to be a decimal. So if you look at your table, you're going to see you skip right over the highest point. Okay, you can see when you first launch it, it's 0 feet off the ground. Okay, and I believe we're dealing with feet. Yep. So make sure you realize your y's are feet. After 1 second of being in the air, we're at 32 feet. Okay, so then it somehow peaks between 1 and 2, so 1.5, that'll be the halfway point. And then it comes back down after 2 seconds at 32. And by the time that you look at 3 seconds, it's back to the ground. So it's only in the air for 3 seconds. So your vertex is halfway between 0 and 3, which is 1.5. So we know 1.5. Let's have our table. So I showed you this. Second Windows allows you to put in any number you want. So in this case, I want my table to tell me, hey, when X is 1.5 seconds of this water balloon being in the air, I can see it reached its max height of 36. So 1.5 seconds in the air, 36 feet is the max height. Okay, I just need you to be able to visualize that. What does the vertex mean? And I basically said that. I'll just rewrite this again. After 1.5 seconds, the balloon, the water balloon, but I'll just say balloon, reaches the max height of 36 feet. So just use the proper units. So whatever the context is for your word problem on your test, use the correct seconds, feet, use the correct units. Okay. How long does the balloon remain in the air before hitting the ground? We already saw that. I'm going to have my table start back at 0. We can see it's back on the ground after just 3 seconds. Your X's are seconds. Your Y's are the feet, number of feet above the ground. So when it's back to 0, we know it was in the air for 3 seconds. Okay. Now, I am not going to take this away from your test. We saw it originally in chapter 1. We had a pretty easy problem in chapter 1. I don't want you to forget how to solve a system involving X, Y, and Z. So here's the hint. I don't have Z's in this third equation. On your test, one of your equations is going to be missing a variable. It could be missing the X, Y, or Z, whatever one that's missing. You want to look at the other two equations and get that variable to cancel out. So if I'm missing my Z's, and the nice thing about this problem, my Z's are already opposites. So I'm simply going to add these top two equations together. And the reason I want to do that is I want another equation with just X and Y. And if I have two equations with X and Y, I can solve like we did in Algebra 1. So I'm simply going to add these. I don't have to multiply by anything. I already have opposites. So when I add, I'll take the time to rewrite this top equation. And I'm going to rewrite the middle equation. And the good news is simply adding, the Z's disappear. And I get another equation with just X and Y. I put this equation and the one we just created, put them together. And we can see right away, again, no work. We don't have to multiply to get opposites. I already have opposites for my x's. So if I add right away, the x's disappear, and I'm going to be able to quickly calculate. Again, be careful of your signs. A negative 6y plus 4y is negative y. A negative 24 plus 16 is a negative 8. We divide by negative 2. These are all your Algebra 1 skills. We're going to get a y value of 4. And if y is 4, I can plug it into this or this. I'm going to happen to just plug it in here. Okay, it's my choice, your choice. Whatever you plug it in, you should get the same x value. So I'm going to show 4x minus 6 times 4 equals negative 24. 4x minus 24 equals negative 24. When you add, you get 0. Now, that doesn't mean it's a special case, okay? It's not 4 equals 0. It's 4x equals 0, which means I can still solve for x, and I know my x is going to be 0. So the only variable we're missing is a z. So I have two choices. I can plug it into the top. I can plug it into the middle. I'll plug it into the middle. So I'll show the work right here. I have a 2 times 0 plus 5 times 4 plus 4z equals 8. Okay? This is just 0. That cancels out. This is a 20. Oops. So 20, 5 times 4 is 20. I'm going to take that 20, move it over to the right side of my equal sign, where I'm going to have 8 minus 20, which is negative 12. And when I divide, I feel good that z is negative 3. So final answer, put it right as an ordered triple. We have 0 for the x, we have 4 for the y, and we just found out that z is negative 3. It will work out very similar on your actual test, okay? And this is the only set of points that when you plug it in, you get true statements for all three equations, okay? So it works for all three, which brings us to our last page. Now, you're only going to have one of each on your test. I have you practice 2 problems of each form. So this is where I will have written, if I want it in vertex form, you'll see on your test, I'll give you this formula, okay? Y equals A times the quantity x minus h squared plus k. You need to make sure going into this that you identify your vertexes as hk. It cannot be xy, okay? Your xy is just a random point. So it somehow passes through 3, negative 4. That's what I call xy. And so once you label your points correctly, it should be very easy then to replace the y with, in this case, a negative 4. The a we don't know. We know x is 3. We know h is a 7, so 3 minus 7 squared. And then k is a negative 8, so I can just say minus 8. Okay? And it should be relatively easy to solve for a. So if you need a calculator, I know this is going to be 16, but if you can't see that, then go to your blank screen on your calculator, use parentheses, and type in this part, 3 minus 7 squared. The calculator tells me 16. Now, I like writing 16a. Okay, a times 16 is correct, but it looks better to me if it is 16a, and then minus 8. Okay, now it's super easy. Add an 8, get rid of that 8, send it over to the other side. You're going to get a 4. And now I'm going to divide by 16, and don't panic if you get a decimal, okay? We have to keep in mind that we can have vertical shrinks for these problems. And if you take a calculator and you type in your 4 first, 4 is on top, you're going to see it's nothing more than 1/4, okay? It's 0.25. A is 0.25 or simply 1/4. So I don't care how you write it, but don't stop once you find A. You still need to write your rule. So my rule is 1/4 x minus 7 squared minus 8. Someone should be able to look at your rule and know why the vertex is 7, -8. 7, -8. And if you type that into your calculator, you go to your table, you'll also see that the graph contains 3, -4. Okay? If you can do number 7, then number 8 is done the exact same way. So with number 8, all we're going to end up doing is labeling HK again, and then XY. Now, maybe on your test, I give you a graph. You just will need to look at the graph and identify the vertex, the lowest or highest point of your graph, and then pick a point. So look at your notes if you need more examples where I just give you the graph. But I'm going to simply rewrite. I'm going to use this formula again, and my Y is a 1, my X is a -4, my H is a -2, so minus a -2 is +2, and then +5. Okay, so again, it should be very easy to substitute into this formula. You replace the letters. If they're identified correctly, it should fit right into your formula, and now you just have to calculate. It's not that hard to calculate and solve for A. This, again, use parentheses if you need to. If you can't do this in your head, I don't want you to get a calculation wrong. I know that's going to be a 4. The calculator knows it's a 4. You need to know where that 4 is coming from. -2 plus 2 is -2 squared, +4. So I'm going to squeeze a 4 in front. I like it in front. A4 is the same as 4A, and then +5. I'm going to subtract 5 on both sides. I'm going to get -4. Let's line up my equal sign nicer. And I'm going to divide by 4. And I'm going to get A is -1. And if I would actually graph this, my vertex is a max. Okay, I know it opens down. Y equals, you can just put a little negative. If you want to write -1, you certainly can. I'm just going to put a little dash. And then I have X plus 2 squared and a +5. And I could type that in my calculator. I would see the vertex occurs at -2 and a 5. Okay, that's just to the left. Okay, which leaves us our last two. Okay, at this point, half hour in. Like I said, you're only going to have one of these to do on your test. Okay, I'm having you practice 2 of them just to make sure you understand. You can do these. You can do the ones that are going to be on the test. Here now, I'm asking about the intercept form. So write in intercept form, I'll have this on your test. Okay, we use P's and Q's. That's just what the book uses. So when I tell you the intercepts are 3 and -6, label one of them as P, the other one's going to be Q, and then I have some random dot that's on that graph as well. So my Y is 90, my A I don't know, my X is 0, so I'm going to have 0 minus 3 squared. Oh, sorry, not squared. I was getting used to vertex form. Parentheses, 0 minus -6 is +6. Okay, so A times, this is nothing more than -3. This is nothing more than a 6. If you need a calculator to take -3 times 6, you'll get -18. And that is what A is. So it's -18A. I divide by -18. 90 divided by -18. And I get a -5. Okay. Y equals -5x minus 3, x plus 6 is what I can type in the calculator, hit graph. I'll see the graph crosses the x-axis at 3 and -6. It's going to be an upside down, pretty skinny parabola, okay, because it's a reflection and a vertical stretch. Last one, and then we are done, and hopefully this all makes sense that you can go into your test with lots of confidence that you can do this on your own. Okay, there's plenty of problems to try. The big idea assignments, you're practicing all this, the notes, make sure you can handle a problem where I tell you the intercepts and I give you a point. Okay, so this time it's 18 equals a times my x minus -1. So I'm going to put +1. And I'm going to have my x minus -4. So I'm going to say +4. And I'm going to calculate this. So it's a times 3 times 6. 18 equals 18a. That just tells you, hey, it's not a stretch or shrink. It's just a 1. And my final answer, I could put a 1 if I wanted to, or just leave it blank here. And it's going to be x plus 1 and x plus 4. And I'll quickly, since I have some time yet, I'm going to quickly just verify this. So if I wanted to, I look at the clock, I still have more time. I can verify that we did this correctly because I should see a graph that crosses the x-axis at -1 and -4. And if I go to my table, I should see the point 218. And we see the point 218. That is the only rule that meets these conditions. Okay? I have a few more questions where I wanted to practice finding the vertex when we are in standard form. So just a reminder, standard form is your ax squared plus bx plus c. I even remind you, this is how we're going to find the line of symmetry, which is the x value of our vertex. So before we even pick up a calculator, I know that a is 2, b is 18, c, which is really the y-intercept, is going to be all the way up at 43. So I'm really only interested in opposite of 18, so it's -18, over 2 times 2. Okay, so this is really going to be -18 over 4. It's really -9/2. And if I actually divide, I'm going to get -4.5. Okay, half of -9 is -4.5. So I know that's where I'm going to have to go on my calculator. Okay, I'm going to need to find when x is -4.5, what the y value is. So all I need to do is go to the y equals screen, hit clear, and 2x squared plus 18x plus 43. So I just have to make sure I type the roll in correctly. And now I can just have my table start at -4.5. As soon as I go back to my table, I know that the y value becomes 2.5. And there's your vertex. Okay, so you can confirm it by the graph. So if I hit graph, I can see that this value, I can somewhat see it's at -4.5 and then up, and I can zoom in, it's up 2.5. Okay, but that is, in this case, the minimum. Okay, the next problem, standard form. I pick out my A, I pick out my B. Yes, I can pick out C. I really don't need C for this problem other than knowing that that's my y-intercept. But I'm going to take opposite of -10, which is 10. 2 times -2, it's going to be 10 over -4, which is really -5/2, which is -2.5. Okay, now you can use a calculator if you need to divide, but I know my vertex is going to occur when x is -2.5. So I go back to the y equals screen, clear it, type in my new rule, negative, make sure you have negative and not a -2. So it's -2x squared minus 10x minus 15. Oops, I forgot my x. That would have messed me up. -10x minus 15. So I'm going to have my table start at -2.5. I go back and I see, well, then my y value is going to be -2.5. Okay, I can hit graph to confirm that. Okay, and like I said, if you could extend this, it's going to cross the y-axis down here at -15. Okay, here's -10. is going to cross at negative 15 as your y-intercept. But the main thing is, can you look at a problem in standard form and find the vertex? That's what I want you to be able to do. Okay, this last 4 questions all involve factoring. So I want you to make sure you know how to factor, and then from factored form or intercept form, I want us to be able to find the vertex. So for this problem, always remember GCF. So this is a very easy problem, but it confuses a lot of students because it's just x squared plus 3x. All you can do is factor out an x. Okay, so there's my factors, and I now define my intercepts. I know what makes an x 0 is 0. I know that graph's going to cross the x-axis at 0, and what makes this 0 is a negative 3. Okay, and I can confirm that. So I'm going to type in my original problem. So I factored it. There's the factored form. And I'm going to type in x squared plus 3x. And when I hit graph, I'm going to confirm that I have the correct intercepts. Here's negative 3 is where it's crossing, and then there's 0. So then to find the vertex, that's when it's your P's and Q's. I basically have to add these numbers together and divide by 2. So it's the average of your intercepts. So to find my line of symmetry, I simply add these numbers and divide by 2. Well, negative 3 over 2 is nothing more than negative 1.5. Okay, so then my vertex is negative 1.5, comma, and I need to find that. So whatever this number is, it looks somewhere around negative 2, but I can go to my table, have my table start at negative 1.5. I go back to my table, and I know it's going to be negative 2.25. Okay, there's your vertex. Okay, for number 14, I told you to fix. We don't know how to handle cubic functions yet, so I needed you to fix this, rewrite this as a quadratic function. But to factor this, I'm going to factor out a 2 first. I'm going to make this problem easier since I have a GCF of 2. All these numbers are even. Therefore, I can factor out a 2. This will make the problem so much easier. Now, what's left over can be factored. So that 2, all that 2 is telling us is it's a stretch. Okay, we're not going to do anything else with that 2 other than knowing that it's a stretch. And then I'm going to factor this trinomial. I know it's x minus and x minus. You say, how do I know that? I have a positive 20. Whatever this number is times this number must give me a positive 20. But then I also have to make sure it adds up and agrees with that negative 9x. So I already know the numbers, but you would have to think. You may take a while for some students. 20 and 1, 2 and 10. You'll eventually know 4 and 5. Okay, x times x is my x squared. Outside, I get a negative 5x. When I multiply correctly here, I get a negative 4x, but together is a negative 9x. Negative 4 times negative 5 is a 20. So that lets me know 4 is an x-intercept and 5 is an x-intercept. Okay, so I can confirm that right away, and I'm going to type my original function in. So that 2x squared, so I'm typing in before I factored, and it should tell me the same story, and I'll know that I factored correctly when I see this graph and it's crossing at 4 and 5. So it's right there, 4 and 5. I'll even zoom in on this. So zoom, and we'll zoom in. I'll zoom in over here. Okay, so we know there's your 4, there's your 5, and now we need to find this. We need to find the vertex. Well, I know halfway between 4 and 5, if I add them up, I get 9 divided by 2 is going to be 4.5. So all I need to do is go to my calculator. I know it's going to be a negative number, and it's going to be somewhere between 0 and 1. So I'm going to have my table start at 4.5. I'll go back and I can see, well, it's actually negative 1/2. So negative 0.5 is my vertex. Okay, and the graph confirms that. Okay. So then the next problem, easy problem to factor. There's no GCF. So I'm just going to have two sets of parentheses, x and x. Since it's a negative 18, I need a plus and a minus. And I'm going to sit here and think of ways of getting negative 18, put it in numbers here, and then I need a combination that can agree with a negative 3. Okay, 2 and 9 won't work. 18 times 1 won't work, but I'm hoping you know that 6 times 3. Okay, and in this case, I must have the 6 next to the minus. You may say, why must the 6 be next to the minus? I need to make sure that when I do my outers and inners, this adds up to the middle term. So a 3x and a negative 6x agrees with minus 3x. Okay, it's the same, it's equivalent. But in this form, it allows me to know my intercepts, which in this case is going to be a negative 3 and a positive 6. And all I'm going to do is confirm that. So if I type in, and I would type in the original rule, so x squared minus 3x minus 18. Okay, we better see a graph that's crossing the x-axis at negative 3. So right here is negative 3, and over here is positive 6. We know we factored correctly. So we're going to learn throughout the whole year that these x-intercepts are very important. So we should be able to go from intercepts to factored form very, very quickly. So now I just need the halfway to find the vertex. I know the y value is down here. Okay, so to find the line of symmetry, the x value of my vertex, I add these numbers together and I divide by 2. So I'm going to get 3/2, which is 1.5. Okay, so I know my vertex will occur when x is 1.5. I expect my y value to be well below negative 10. Okay, so right here's negative 10. We're down here, maybe negative 15. So let's see. Let me have my table start at 1.5. I go to my table. Hey, it's way down at negative 20.25. Okay, that's the lowest point on that graph. Okay, all the others. So I need to know that if I had to state the range. The range would be all y values greater or equal to this number. Okay, so the last one, again, looks weird. It's just like number 13, but it's super easy. All you can do is factor out an x. So if I factor out my GCF, I am left with x and then x minus 5. What makes this 0 is 0. So if x is just your factor, it's just an x, you know your graph's going to cross the x-axis at 0. It's also going to cross at positive 5. Okay, so those are your P's and Q's. And just like all the other ones, I'll quickly confirm that we did this correctly by typing this into my calculator. I hit graph. I better see 0 and 5. So let's see. There's 0. Hey, there's 5. I feel like we did that correctly. And I just need to know this point right here. I need to know the minimum in this case. That's where the vertex is located. So I simply add these numbers together and divide by 2. I take half of 5. I get 2.5. So that's where my x value of my vertex is. That's my line of symmetry. I have my table start at 2.5. I go back to my table and I can see, hey, it goes down to negative 6.25. There's my vertex. Okay, so that's everything you need. I even put extra practice problems. You're not going to have this many problems on your test, but it is important that you understand everything that was on this practice. Okay, so when you take your test, I feel that you should be more than prepared to do well on the test if you understand everything on the practice, you understand your assignments for the big idea assignments. I'm hoping for great results. So do your best. If you have any questions, please do not hesitate to come to me, send me a message, and I will try to help you the best I can. So thanks for watching. Take care.